Hello, here is your problem. 3 times x minus 2 plus 4 is 13. Okay, so what I always do and try to teach my kids to do is to ask yourself questions, then answer them. And the first question is, why is x not alone? Well, it's got all kinds of stuff over here. And we want x to be by itself on its side of the equal. So we want to have x on one side and a number on the other side, which is the answer. And we work from the outside in. We start with things away from x and work closer to x. So the first problem is this plus 4. It needs to go to the other side because it's further away from x and it's on the wrong side. We're going to have numbers on this side, letters on that side. So the first thing, and how you get x by itself is by doing the opposite. So we have a plus 4, so the opposite is minus 4. And in math, you could do anything you want, which makes me feel very powerful, as long as you do it to both sides of the equals or to the numerator and denominator of a fraction. Okay, but we don't have any fractions, yay. And so we're going to just do things to both sides of the equal. So if I do minus 4 on this side to get rid of it, I've got to do minus 4 on that side. Then I bring down anything I didn't mess with. So I have 3x minus 2 equals 9, because 13 minus 4 is a 9. Now, there's always more than one way to do a math problem, but I'm going to show you the way I like to do it, and I'm not going to show you the other ways because I have found that when you show students a bunch of different ways to do a problem, that they'll sit there and watch you and kind of follow along, but at the end it gets scrambled in their brains and they don't know anyways. So I'm going to just show you my way. This is it. Okay, so the next thing, what's making this problem ugly? I always ask yourself that too. Why is it ugly and can I fix it? And it's those parentheses. They're ugly. But we can use the distributive property, and we're going to get rid of our parentheses, and then it'll be prettier. So the parentheses in math mean times, and so this is 3 times x, literally, and you can't just do it to the x, you have to multiply it also times the negative 2. So 3 times x is 3x, and 3 times negative 2 is negative 6. Bring down what you didn't mess with, equals 9. So now, why is x not alone? Well, it's being multiplied by 3 and it's got a minus 6. But remember, we always work from what's further away to what's closer. So what we're going to get rid of first is minus 6, and the opposite of minus 6 is plus side 6, and what we do to one side, we do to the other. And you see how that gets rid of these mark out. Plus 4 minus 4 is 0. We could just ignore that. Minus 6 plus 6, we can just ignore that. So now we bring down what we didn't mess with. 3x equals 9 plus 6 is 15. Now, why is x not alone? It's being multiplied by 3. What's the opposite of multiplying by 3? Divide by 3. And we can do anything we want as long as everybody gets it. So 15 also gets a divide by 3. So x equals 5. Put a box around it. Woo, woo, woo. It's more fun if you celebrate. If we were going to graph it, this is y, this is x, this is positive 5. 1, 2, 3, 4, 5. We draw an arrow like that. Whoop, whoop. Da-da! Okay, hope that helped.